Hard to believe. We've all seen the effects of gravity waves. You probably didn't even know.
I probably didn't even know it.
You ever see those lines in the sky, clouds lined up?
Yeah.
That's a gravity wave. There you
I already
go.
learned
We don't
something.
need you today,
Okay.
Jacob. We're done.
We can be done.
Okay, maybe we do.
We'll go a lot more in depth into it because, yeah, you've seen these in our sky before, but you probably just don't know the name of them. And we'll go into that over the next couple of minutes here. The ripples in the sky called gravity waves. Now, they can happen with mountains and terrain. We'll go into that in a second. But envision a stone dropped in a calm pond of water, and then that creates its ripples out in all directions, that up and down motion. And that's very similar to the atmosphere because the atmosphere is a fluid. Fluid dynamics apply to both water and the atmosphere. So with terrain, like I was talking about, mountain pushes up a bubble of air. The momentum carries that bubble up, opposing the pull of gravity. But once it reaches height, the air cools, it becomes denser. Eventually, it starts to sink again. Gravity accelerates that downward motion, and the air warms as it sinks. Now that it's warmer, it's less dense and wants to go right back up. So with the bubble of air now warmer and less dense than the surrounding air, it begins to rise again, and you get this oscillating up and down motion in the atmosphere. Again, it can form thanks to terrain, but you usually need that stable air in place first in order to create these gravity waves, like throwing a rock or a stone in a calm or stable body of water. So the gravity causes the air to fall back down, and it begins to oscillate, creating that ripple effect as it goes over terrain. You can kind of see that out from that mountain with the clouds forming on the crests of these waves. So once it gets into a saturated layer of air, there's enough moisture to form those clouds. With the rising air, it can form those streets or kind of straight lines of clouds. So here's a couple of examples from space when the clouds are forming on those cooled crests of the waves when there's enough moisture present, with terrain being one mechanism performing these gravity waves. So they're not as common in the plains as you can see them closer to mountains, usually closer to Rocky Mountains. The examples from the past slide were from Pennsylvania with some of the mountains there. But from the ground, we can get some of these gravity waves to form in a stable stratus layer of clouds like this. You can get these ripples in that more flat sheet-like of clouds, or you can get them with some blue sky interspersed in between those streets of clouds. So how can we get them in the plains if we don't have big terrain features? They can occur when they're trapped below an inversion layer, and that can allow for that air that's disturbed by maybe a thunderstorm or a front to continue to oscillate in that lowest level of the atmosphere. And the fronts can cause these to form if the density differences are large enough between the air masses. So another kind of explainer here, there are waves in the atmosphere. They occur near mountains or fronts where stable air is forced to rise, usually appear kind of as these long rolls of clouds, with the clouds forming on the peaks or the crests of the waves. And you can kind of envision this as another analogy. If you have a basketball submerged in the pool, if you try to throw it up, it won't immediately stop when it hits the surface of the water. Its momentum will cause it to kind of bob up and down a few seconds. So it's all about kind of momentum transfer here, where the air continues to flow in that wave-like motion. So all of this has to happen with initially stable air, and the momentum keeps the wave going. With that stable layer of air, the warm air aloft stops the upward motion, and the air can sink again, forming that gravity wave. Whereas if we had an unstable atmosphere, and this is what the profile, the temperature profile of that atmosphere would look like from the surface to aloft, the rising air would keep going in that unstable atmosphere, and we wouldn't get the gravity waves. With the stable air, again, you can get that oscillating wave-like motion within that lowest level of the atmosphere. So trigger mechanisms, terrain, thunderstorm updrafts, that can create that rising air and the ripple effect out from that updraft, or fronts. And with these types of gravity waves, it can create clear air turbulence for aircraft. So if you look at the schematic here, we have our stable air, the terrain feature is creating our gravity waves and creating those clouds in those streets, but this translates up into the upper levels of the atmosphere, and that can create for some turbulence or some bumpiness if you're flying through these types of gravity wave phenomena in the atmosphere. So other gravity wave examples, this was from the Minot radar a number of years ago, initiated by thunderstorms. The outflow created some clouds, and you can actually see them on radar there. Similar example here on satellite. outward from a thunderstorm complex, and another example near Minnesota with some of those wave clouds on satellite imagery. Now, a different type of wave-like cloud that'll look very similar from the ground is called horizontal convective rolls. The only difference between gravity waves and these are the mechanism in which they form. Horizontal convective rolls are due to strong surface heating with a fairly steady wind direction. And you get this rising air with a capping inversion, so the air can't rise any further, similar to like what we have with the gravity waves, and you can get these horizontal convective rolls to form. So you have the rising air, it condenses, there's enough moisture to form those clouds, and then it sinks kind of in that convective nature. That's where the name comes from, and kind of like in your oven, this is a little bit of a tastier version of the horizontal convective rolls, but you get the idea with a couple of those satellite images up there about what we're talking about. So horizontal convective rolls and then some gravity waves, kind of those street-like straight lines of clouds in the sky. We can get them here also off of the Black Hills. They can even propagate, or there's enough of the wave-like motion in the atmosphere to come all the way here into North Dakota to form those gravity wave clouds.
But did you bring the tastier version?
I did not.
Looking around for that.
That was my
You
mistake.
could make that,
You
though.
forgot
we
something,
can-
Jacob.
Those convective rolls we like. You know,
Yeah.
we want to taste them.
Yes,
So,
exactly.
yeah.
All right. Well, thank you,
Yeah.
Jacob.
Thanks a
Good
lot,
stuff.
Jacob. Good stuff.